already learned about the few logic operation instruction by using the C program. Okay, now we are going to look at another example. Okay, how to perform a logic operation. Okay, how to use a logic operation in C programming. Okay, so in this example here, you see here, okay, you are going to write an FVRC program to monitor bit 5 of port C. If it is high, okay, if the bit is high, you're going to send 55 to port B, otherwise send AA to port B. So now what happened here is, okay, you have this your Atmega 32. Okay, so you can locate your Atmega 32. Okay, you draw up your Atmega 32 and find out what are the information that you get from this question here. Okay, so in this case here, okay, you're going to write a program to monitor bit 5 port C. Okay, you're going to monitor bit 5 port C. Let's this is a PC5. Okay, you're going to monitor it. Since you're going to monitor this one here, okay, the PC5. Okay, so this PC5, we need to make it as an input port. Okay, so every time every time there is a monitor. Okay, wait, yeah, my cursor is not function very correctly. Okay, so now you're going to monitor bit 5. So this is okay, you're going to monitor the bit 5. So never mind. I cannot. Good job. Okay, so now since you are going to monitor bit 5, okay, so my cursor is still not working. Okay, so if it is high, then what you're going to do here is you're going to send 55 to port B. So you have a port B. So let's this is your port B. Okay, and since it is a monitor, so what happens here is you're going to make this PC5 as an input port. Okay, so every time you hear the word monitor means that it is an input, which is you're going to monitor either the switch is pressed or not. Okay, so this is okay. So you're going to monitor either it's a logic 1 or logic 0. And then you have a port, and it says that, and this is your port B, okay, and it's telling you that, okay, if the PC5 is high, okay, whenever the PC5 1, which is high, so what happened here is port B equal to 55, and when PC5 is low, then port B sama dengan AA. Okay, so this is the information that you get from this question here. All right, so what you're going to do here is, mula-mula, okay, we need to identify, okay, what is the input-output port that you're going to use from this question. Okay, so since this one here, you have two input-output port that you're going to use. One is a port C, and the other one is a port B. So you need to make sure that, okay, port B become your output, while PC5 is your input. Okay, so now you can start with writing the program. Okay, so how to write a program? So first thing first, okay, what you're going to do here is, okay, you need to initialize your input output port. Okay, so you started with your main program. Okay, and make sure that before you start with your main program, make sure that you include this header file. Okay, include avr/io.h. Okay, and then after that, okay, under the main file, okay, so this is first initialize your input output port since you have two input outputs, okay, two ports that you're going to use. One is port B, so DDRB equal to 0xFF. Why FF? Because you're going to make your port B as an output port. And then port C, since your port C is connected to switches, okay, which is your input, okay, you can simply DDRC equal to 0. Okay, just initialize the whole port C as a input port. Or sometimes, if you don't want to initialize the whole port C as an input port, okay, you can do by initialize only PC5 as an input port. So how to do that? Okay, you can simply write DDRC sama dengan 0B. Okay, I always use a 0B lah. Okay, a binary number because we're going to initialize only one PC5 as an input port. So what happened here is 1, 1, 0, 1, 1, 1, 1, 1. Okay, so this is another way lah to do it, which is only PC5 sama dengan input while the rest is become output. Okay, so it depends. Okay, this one also correct. Either you're going to make the whole port C as an input port also correct, or you're going to only the PC5 is become your input also correct. So, but make sure that the location here is betul lah. Okay, and then okay, before we proceed with the other coding, okay, the other codes. So since you are all since your port C is your input port, okay, so it is advised for you to enable the pull up resistor. Okay, so macam mana nak enable a pull up resistor? Okay, you can put a D. Okay, so yang ni tak ada ya, DDRD, OXX, FF ni tak ada. Okay, so you just cancel this one here. Okay, so make sure that you cancel this one. Yeah, I don't know why I cannot write on top of this one. Yeah. Okay, so number one. And okay, so I'm going to enable the, since this one is connected to input, okay, DDRC is connected to input. So I just simply write port C sama dengan 0x FF. So this is to enable pull up resistor. Okay, later we will see why we need to enable the pull up resistor. Why is it is important to enable the pull up resistor every time, okay, you use a switches. Okay, and then after that, okay, since it is, you're going to monitor it continuously. Okay, you're going to monitor this input, okay, your switches here more continuously. So what happened here is, okay, we need to use a while loop. Okay, so while one, so means that it will continue. Okay, you will keep doing the code inside of while loop continuously. Okay, so inside here you open curly bracket and close curly bracket. Okay, so what you're going to do? Okay, now we are going to check whether, okay, the PC5 is 0 or 1. So how to do that? Okay, you can use the if statement. Okay, if else statement. Okay, so if pin C equal, okay, you can use this one as well. Pin C end with 0B0010000, okay, which is you're going to check bits 5, okay, either is a 1 or 0. Okay, if you have 1, so what happened here, you need to send this value here. If 0, then you're going to send this, or you can simply write something like this: pin C equal, okay, what is the value that you're going to check? 0B0010000. Okay, which is this is equivalent lah, sama je ni dengan this one. Okay, and okay, so check PC5, is it sama dengan 1? If yes, what happened? Okay, if yes, okay, port B equal to 55. So what happened here? Port B equal to 0x55. If not, what happens? Okay, you put a else lah. Else port B equal to OXA8. So this is how, okay, to monitor a PC5, okay, an input from port C pin number 5 and send out the output to port B according to the value that you will receive from PC5, okay, by using a logic operation. Okay, so the logic operation is actually this one lah, okay, yang N ni, this N here, okay. So this is another way lah yang saya tulis ni, this is another way, okay, to check the prinsip, okay, by using this symbol here, and, sorry, equal, which is to check sama ada dia sama dengan 1 or not. Okay, and then moving on to the next slide. Okay, and then we have the bitwise operation in C, okay, which is another one is a shifting. Okay, this is how to do a data shifting. Okay, earlier in the assembly language, you already learned how to do a data rotation, data shifting by using the ROR, LSL, LSR, ASR, etc. And by using a C program, you can also do that by using this symbol here. Okay, so this is the symbol, okay, for data shifting. Either you're going to shift right or shift left. Okay, so the value after this symbol here, okay, any value after this symbol, okay, will indicate, okay, the number of the shifting. Okay, so any value after this symbol, will indicate how many bit that you're going to shift. Okay, for example, we look at the first example here. Okay, so you have a 0B0001, 0000, and shift to the right how many times? 3 times. So this is how many times that you're going to shift. Okay, so what you're going to do here is, since this is to shift to the right, okay, so this symbol is shift to the right. So usually selalunya kita buat is, okay, we take from MSB, okay, and then shift ke kanan. 1, 2, 3. So this 0 will go here. What about the rest of this bit here, yang ni? Okay, this bit here will follow lah. Alright, so it becomes 0, 0, 1, 0. And this 3 bit yang belakang ni, okay, will go outside lah. Okay, we go outside. And what about the bit before that? Okay, it will fill up by 0. Okay, not this bit, yeah. Okay, because we are not doing the ROR. Okay, rotate right. Okay, which is the value coming back to your this bit here. No, okay, since every time you use this one here, okay, this symbol, okay, after you do the shifting, okay, this bit here will be filled up by 0. Always will be filled up by 0. So this is the value after you do the shifting to the right 3 times. Okay, let's look at the second example. Okay, you have the 0B0001 and 0000. Now, okay, you see here, shift to the left. How many times? 3 times. Okay, so yang ni, if shift to the left, what you're going to do is, we'll always take the least significant bit and go 3 bits to the right, to the left, 1, 2, 3, and this 0 will go here. What about the rest of this bit here? This rest of the bit will follow lah. Okay, will be shifted. 1, 2, 3, and this bit one go here. What about this 3 bit? This 3 bit will go outside lah. And how about this bit here? Okay, this bit here will be filled up by 0. Okay, and this is the value, which is after you did perform this data shifting, okay, the value that the result that you will get is equal to 80. Okay, yang ni tadi equal to 0, 2. Okay, and sometimes, okay, we can tulis something like this, right? So 1 shift 3. Okay, what is this? Okay, so this is the value lah. Okay, so this is the value, and this is the number of shifting. Okay, so 1. What is a 1? So you need to convert it to a binary. So 1 is a 0, 0, 0, 0, 0, 0, 0, 1. Okay, now you're going to shift it to the left. Okay, from here, 1, 2, 3, 3 times. Okay, and the rest will follow lah. Okay, what about this one here? Okay, this one will fill up with 0. So this is the answer. Contoh, another contoh I give you. Okay, 7. Okay, don't want to shift to the right. Okay, because the jawapan will be 0. Okay, so what happened here? Okay, so this is the value. Okay, the numbers, and this is how many data bit that you're going to shift. Okay, first, convert this 7 to binary representation. Okay, you will get 0, 0, 0, 0, 0, 1, 1, 1. Okay, it's 1, 2, 3. Sorry, 1, 2, 4, 8. Okay, so this is a 16, 32, 64, and 1 to 8. Okay, 4 plus 2 is 6, plus 1 is 7. So that's why you get this value here. And then after that, shift to the left how many times? 3 times. Okay, so 1, 2, 3, 4, 5, 6. So it will go to this bit here, and the rest will follow. Okay, what about this bit? This bit will fill up with 0. So this is the final answers. Okay, so this is the symbol for data shifting. Either you're going to shift it to the right or shift it to the left. Any question up until here? Ada soalan tak? Okay, so this is the pengenalan lah, the introduction of C programming. Okay, if no question, okay, then we continue our class here with the I/O introduction. So, introduction to input output. Okay, I assume that you already learned about the input output in ArcMega 32. Okay, but by using the assembly language. Okay, now we are going to look at how to make the input output port by using the C programming. Right, so this I/O introduction, okay, so common I/O interface, okay, there are 3 common I/O interface. First is the elementary I/O. Okay, what is the elementary I/O? It is a simple two-state device such as LED and switches. And then we have the parallel I/O, okay, which is the data will exchange 1 byte at a time. And the serial I/O, which is the data will exchange 1 bit at a time. Okay, parallel means that you send out the data parallelly. Okay, so if you have a 8-bit data, so the 8-bit data you will send out at the same time. But if you use a serial I/O, means that you need to send it bit by bit. Okay, 1 bit by 1 bit. So that's why we call it as a serial I/O. Okay, before that, I need to right, so let's look at the ATmega 32 input output part. Okay, as you already know, okay, we have a total of 40 pin out. Okay, started with pin 1 until pin 40. Okay, you have a pin 1 until pin 40. Right, so from this 40 pin, okay, 32 of them is dedicated to your input output port, which is 8 is for the port A, another 8 is for the port B, 8 for the port D, and another 8 is for the port C. So a total of 32 pin out, okay, are dedicated to your input output ports. Okay, then the rest of the bit is you have the reset, VCC, ground, okay, oscillators, AVCC, and a ref. Okay, and the pins, okay, that are marked with a G and D are to be ground. So every time you see here, okay, G and D, you need to connect it to a ground. And VCC, sambung connected to your 5 volt. Okay, so all the VCC need to connect it to 5 volt. Okay, so this one also connected to 5 volt. While reset, okay, the reset here, which is a pin 9, okay, need to connect to active low switch. Okay, so this reset button here is used to reset your microcontroller. Okay, why need to connect to active low switch? Because this reset here is will be triggered when it receives a low signal. Okay, so that's why you need to connect to active low switches. Okay, when you press this switch, okay, what happened here is the zero from this ground here will be go to your reset. So the zeros value will be sent to your pin 9 every time you press this switch. Okay, and then okay, so that is the things that you need to know lah. So every time you use a Atmega 32 port, okay, never mind, because this connection here is already been done. Okay, when you buy your Atmega 32 board. Okay, so you no need to to do this connection, right? Okay, so there are three registers associated with the input-output port in AVR. Okay, as you uh, learn in the previous module. Okay, every time you use a I/O, so there are three registers which is associated with a I/O, which is we call it as a DDR registers. Okay, we have a DDRX registers, and then we have a port X registers and pin X register. So every time you use a port A, so you have the DDRA register, port A register, pin A register. If you use the port B, then you have the DDRB, port B, and pin B. Okay, so what this register do? Okay, for the DDR, okay, so this is actually to determine, okay, a given port is it as an input port or as a output port. Okay, so this is the function of DDR. Either you're going to make it as an input port or as a output port. Okay, to make it as an input port, okay, you need to put 0, okay, to your DDR. And to make it as output port, what happened here is you need to send or put 1 to your DDR. Okay, when your port become your output port, so what happened here is, okay, so you will use this port, okay, to send out data from your microcontroller or micro P to the outside world. So every time you're going to send out data from microprocessor or from your CPU to your outside world, okay, we're using the port X. Okay, meanwhile, for the pin X register is used to read a data. Okay, so this one is to read, okay, to read the data inside your CPU or microcontroller from the input, okay, peripherals. Okay, so this is the pin out. Okay, you see this is the pin out. Okay, you have a total of 8 bits. Okay, started from PX7 until PX0. And then inside here, you have 3 registers, which is the DDRX, port X, and pin X. Okay, so now we are going to look at how to do a I/O programming. Okay, so how to do a I/O programming by using in C program. Okay, first, okay, what you need to do is you need to learn how to initialize your input output port. So that is the first thing lah that you going to do. Okay, so how to make the I/O port as an input or as a output. Okay, so the answer is you need to initialize your DDRX register. Okay, so to make a port and an output, okay, so what happened here is you're going to make sure that you write, okay, you need to set or you need to initialize it inside of your DDRX register. Okay, so as I mentioned here, okay, so this DDRX register is very important in order to determine either you're going to make your port as an input or as an output port. If you're going to make it as an output, so what happened here is in this DDRX, you need to give 1. Okay, input, give 0 to your DDRX. Okay, for example here, okay, you're going to make a port B as an output. So what happened here? Okay, port B, how to make it as an output. So what are you going to do? Okay, since this is the whole port B lah, okay, let's assume that the whole port B, you're going to make it as an output port. So what happened here is, okay, you need to have, this is your DDRB. Okay, since your DDRB is a 8-bit size, okay, the size is 8-bit. Okay, looking back at this figure here, okay, so this is your DDR. DDR size is 8-bit. So what you're going to do here is, okay, since you're going to make the whole port B as an output port, so what happened here is, okay, to make an output port, so you need to send 1 to your DDRB. Okay, so this is the value lah. Okay, so what happened after you send 1 to all bits of your DDRB, so automatically your port B sekarang become output port. Okay. Okay, so earlier, okay, when you learn in assembly language, okay, so what you're going to do here is, okay, you write down LDI, okay, R16 OXFF. Why OXFF? Because this one is 8-bit, 8-bit 11111. Why? If you change to hexadecimal, okay, you will get FF. So this FF, before you send to your DDRB, so what happened here is you need to put it to your register first, your general purpose register. How to do that? By using the LDI instruction. Okay, so that's why LDI R16 OXFF. So means that you put value, you load value FF to R16. So what happened here is R16 will have values FF. And then after that, okay, you out using the out instruction DDRB R16. So what happened here is DDRB will have value from R16, which is FF. So after you did it, okay, so this is what happened inside of your DDRB, which is all the bits inside of the DDRB will have value 1. Okay, and automatically after you execute this line here, what happened? Your port B will become output port. Okay, this is when you use the assembly language. Okay, now we're going to write in a C program. So how to do that? Okay, it is quite similar. Okay, with this one here. Okay, with the assembly language, only that we are not using the general purpose register. Okay, so we have the DDRB. Okay, you'll simply write the DDRB. Okay, equal to, okay, put the equal. What value that you're going to send to DDRB? Okay, the value is FF, followed by the semicolon. So automatically, when you write this one here to your C programming, and what happened? Port B become output port. As simple as that. Okay, so this is by using a C program, and this one here by using a assembly language. Okay, so bear in mind that, okay, remember every time you're going to make an output port, make sure that you put 1 to your DDRX. Okay, next, you're going to make a port as an input port. Okay, now you're going to make a port as an input port. So what are you going to do? Okay, again, okay, to make a port as an input port, so what you're going to do is put 0 to your DDRX. Okay, so this is your DDRX. So when you put 0, so what happened here is, okay, when you put 0, so now it becomes the input. Okay, so this is what happened. For another example, okay, make a port B as an input. Okay, so make sure that you correct this one. This is not output, it is an input. Okay, make a port B as an input. So what are you going to do? Since you are going to make the whole port B as an input, so here, what happened here is you have a DDRB. Okay, put 0 to all the DDRB. So after you did this, what happened? All of the port here, okay, pin inside of a DDR port B now become input. Okay, so to do that, you need to write a program. Okay, so first let's look at the assembly language. So this is the value that we're going to put to DDRB. What is the value? If you change it to hexadecimal, the value will be 0x00. Okay, so this value here, you need to put it to your GPR. Okay, once you put to GPR, then you can send it to your DDRB. So this is the step lah. Okay, you need to do in order to put a value 0 to your DDRB by using assembly language. Okay, so how to do that? Again, by using the load I instruction, R17 with what value? With a 0 lah, OX00. Okay, you can simplify by using the 0. Okay, so what happened here is R17 sama dengan 00. And then after that, you use the out instruction DDRB R17. Okay, what happens after you do this one here? DDRB now get value 0, 0, which is R17. Okay, after you did this one, after you execute this line, okay, what happened? Your port B now become input port. Okay, so this is in the assembly language. How to write in C programming? Again, similar what we did earlier in for the output port. Okay, so you have the DDRB. Okay, what value that you're going to put to your DDRB? Okay, since this is an input, to make it as an input, so you just simply write 0. And your port B now become input port. Okay, any question up until here? So this is the how to use the DDRB, okay, data direct register. Ada soalan tak? Okay, if no question, then we will move to the next slide here. Okay, so now we are going to access port register. Okay, now we're going to look at the port X. Okay, what does port X register do? Okay, so as I mentioned earlier, okay, every time you make your port as an output port, so in order to send out a data from your CPU or from your microprocessor or microcontroller to the outside world, okay, you're going to need to use the port X register. Okay, and every time you make your port as an input port, okay, so in order to read a data from your input, which is your outside world, to the microcontroller, okay, you're going to use the pin X register. Okay, so let's look at these examples. Okay, you have a LEDs that are connected to port B. Okay, so we lukis dulu. Okay, this is our Atmega 32. Okay, you draw your Atmega 32 chip, and then okay, so this is a port B. Okay, I just simply put okay, okay, I just simply put the port B not according to the exactly location lah. Okay, so this is for the lukisan purpose. So I put this one here, port B here. Okay, so this port B is connected to LEDs. Okay, so draw lah your LEDs. And this is a 8-bit LEDs. Okay, 8 bits. Okay, so the whole port B connected to 8 LEDs, which is, if you see here, this LED here, okay, the negative LED, okay, the negative terminal is connected to your ground. So we call this one here as a common anode or common cathode. Okay, common cathode. Atau cathode. Okay, so this is the correct way. Okay, common cathode. Okay, because the negative terminal of LEDs is connected to ground, so this case here, okay, I'll be using the common cathode. Okay, and then write an AVRC program that show the count from 0 to FF on the LEDs. Okay, means that, okay, you going to do a counting, and the counting result will be shown to this LED. For example, okay, so you have LEDs, so this is a LEDs. If the counting is 0, so what happen? All LED is turned off. Okay, if a counting is 1, what happened here? This LED will turn on. Okay, when the counting is 2, right? So what happened? This LED will turn on. And when the counting is 255, so what happened here is all LEDs will be turned on. Okay, will be lights up. Okay, since we are using the common cathode, okay, so you need to know lah how the common cathodes work. Okay, so when you give 0 to this LED, what happened to your LED? Is it your LED turn off, turn on, or turn off? If you give 0,
Turn off.
okay, your LED will turn off. Okay, why turn off? Okay, because your ground is logic 0, and here you give a 0. So 0, 0, current cannot flow. So what happened when 0 LED turn off? What happens if you give 1 here? Okay, since this is a logic 0, okay, which is low, and this is 1 high. So since it have a high and low, then the current can flow from high to low. So what happens here? If you give 1, LED turn off. Okay, so now we already know that. Okay, so we are using a common cathode, okay, to turn on the LEDs. We put 1. To turn off the LEDs, we put 0. Okay, so similar to this one. So when 0, 0, so what value that you need to send out to your port B? Okay, you need to send out kosong lah. For 0, 0. Okay, when 1, okay, the value that you need going to send out is 0, 0, 0, 1. Okay, because this LED will be turned on. Okay, the rest of all LED will turn off. Okay, so now back to our question here. Okay, so what are you going to do? Okay, so first you include this file. So include avr/io.hash. Okay, start with your main program. Okay, inside of your main program, okay, you need to initialize your port. Okay, since we have one port here on the port B, so that's why we initialize the port B DDRB equal to OXFF. So what happened here? After you do this one here, your port B become output port. Okay, next. Okay, so I just write here in main void. Okay, so inside here, this is your main program. Okay, first initialize your DDRB. Okay, after you initialize your DDRB, okay, first, because you're going to count from 0 to FF, betul tak? So why not? Okay, we initialize the first value is 0. Okay, because you're going to count from 0 to FF. So why not we change that? Okay, port B equal to 0. Okay, we just reset, okay, or we just put 0 to port B because we don't want port B to have any values. Okay, so to do that, okay, you just simply use a port B sama dengan kosong. So what happened here, after you send this value here, okay, your LED will turn off. Okay, all the LED will turn off. Okay, then after that, we have the while loop. Okay, why while loop? Because you're going to increase the value of port B by 1. Okay, so by using a while loop, okay, open curly bracket and close curly bracket. And to do that, okay, you can simply write port B equal to port B, okay, and plus with 1. Okay, because you're going to increase the number from 0 to FF by 1. Okay, so this is what? So this is your counter. Okay, it will keep increase. Okay, starting with 0, 0 plus 1 it become 1, and then 1 plus 1 and become 2, and it will keep repeating until FF or 2, 5, 5. After that, it will goes back to 0 again. Okay, so this is how you're going to do the program. Okay, to show the count from 0 to FF. Okay, on the 8 bits LED that are connected to port B. Okay, so next, okay, to selecting the direction of a pin. Okay, previously what we have done is, okay, we make the whole port B as an input or the whole port B as a output. Okay, now you're going to have a mix up, okay, mixing the input and the output at the same port. So how to do that? Okay, so to do that, sama juga lah. Okay, you need to do it inside of your DDRX. Okay, so you have a DDRX. So this is DDRX. Okay, a part of DDRX, you make the whole port as an input or output. You can mix them together in one port. For example, okay, so I'm going to make a pin 7 to 4 as an input. Okay, and while the rest of the pin as a output. Okay, so this is a 0, 1, 2, 3, 4, 5, 6, and 7. Okay, I have a port B. Okay, bit 7 to 4. Okay, make it as an input port. So how to make it as an input port? Put zeros lah. Okay, so automatically it become inputs. And then the rest of the bit, pin 3, 2, 1, and 0 become output port. So you put 1. So this one become output port. So now you have a 4 bit as an input and another 4 bit as a output. So how to do this? Okay, you need to do a program. How to do that? Okay, DDRP equal to, okay, you can use the 0B for binary representation. Okay, 0000 for bit 7 and bit until bit 4. You're going to make it as an input ports, and 1111 for bit 3 to bit 0 as a output port. Or you can simply write DDRB equal to 0x also can. Okay, you can use the hexadecimal 0. Okay, similar. Okay, this way is same. Okay, another example. All right, make a odd pins. Okay, pin 7531 as port C as an input, while the even pin, okay, pin genap as a output. Okay, again, you have a DDRC, 8 bits. Zero, 1, 2, 3, 4, 5, 6, and 7. All right, so the odd pins as an input, so all the odds here you put 0 lah. Okay, and even pin, okay, all the even here you put 1. Okay, so what happened here is this one become input, output, input, output, input, output, input, and output. Okay, now you're going to do a programming. Okay, by simply write DDRC equal to 0B, 01, 01, 01, and 01. Or you don't want to use the binary representation, you can use the hexadecimal, and you can also use the decimal representation. Okay, DDRC sama dengan 0101 is actually D is a 5. Okay, 0x5, 5. Right, so this is how you're going to select, okay, a certain bit to make it as an input and another certain bit as a output port. Okay, by writing 1 and zeros to your DDRX register. Okay, any question up until here? Ada soalan tak? Okay, if no soalan, now we go to the pull-up resistor. Okay, so this is the things that I mentioned earlier. Okay, why we need to use the pull-up resistor? Okay, so there is a pull-up resistor for each or every R pin. Okay, so inside of this pin here, for each of this pin inside of your Omega, all of this pin has a pull-up resistor. Okay, either you're going to enable it or you're going to disable it. Okay, so what this pull-up resistor do? Okay, so this pull-up resistor is useful to reduce noise. Okay, since input of the AVR are generally in high states, okay, those make them prone to catching noise and picking up a false signal. So that's why every time you need to make your port as an input port, okay, make sure that you need to enable a pull-up resistor in order to reduce the noise that will pick up by the microcontroller. Okay, so how to enable it? Okay, to activate the pull-up resistor, okay, you're going to put ones into your port X register. And to deactivate pull-up resistor, just put 0 to the port X register. Okay, so pull-up register need to enable every time you make your port as an input port. If you make your port as an output port, no need to enable or disable the pull-up resistor, only for the input ports. Okay, let's look at this coding here. Okay, this coding here without a pull-up resistor. Okay, let's look what this coding do. Okay, kita tengok dahulu yang, okay, we look at the assembly language, and then after that we go to this C program. Okay, so the first include empty2def.inc. Okay, you include this file here because why? Because you're going to use this register labels, okay, instead of the register address. Okay, load I R16 OX00 out DDRC R16. So what happened here? Okay, you know that this two line here, you're going to make your port C as a input port. Okay, because you send 0 to your DDRC. Okay, load I R16 with OXFF and out DDRC R16. So this another two line, you're going to make your port B, sorry, this one, yeah. Port B as a output port. Okay, and then in R60 pin C, okay, means that you read the whatever data, okay, that coming from your input, which is from your pin C register to the R16. Okay, and then load I R17 with 5. Okay, so R17 sekarang ni you put with 5 and add R16 with R17. So what happened here is, okay, you're going to add whatever value from your pin C with R17 with 5. And the hasil, okay, the result of this addition, okay, you're going to send it out to the port B. Okay, so what? You add the value from pin C plus 5 and the result send it to port C, and then you have the rjump L2. Okay, and it will keep repeating. Okay, so it will keep repeating continuously. Why continuously? Because this is not a conditional jump or conditional branch. Okay, if conditional branch, okay, so if the certain condition is met, then the jump will stop. Okay, the branch will stop. But this one here doesn't have any condition, so it will keep repeating until you stop your program. So it will continue forever. Okay, so this is assembly language, and then you're going to translate it to a C program. Okay, first this one here, the first line, okay, equal to this one lah. Hashtag include avr/io.h, and then inside of your main program, okay, so this is your second line, okay, which is DDRC equal to 0. So this is the second line, which is you initialize your port C as an input port. And this is the third line here is actually this one here, okay, which is you initialize your port B as an output port. And then we have a while loop. Okay, while loop is represented by this loop here. Okay, so this is your while loop 4. Okay, the rjump L2 go here and it will keep repeating. So this is the while loop. And then Z equal to pin C. Okay, so this Z equal to pin C is actually equivalent to this one lah. Okay, this is line number 5. Okay. And Z equal to Z plus 5, which is equivalent to these two lines here, which is first you load I R70 with 5, add R60 with R70. So this is number 6. And out port B R16 is actually this is a 7. Okay, line number 7. Of course lah, okay, before you use the variable Z, okay, you need to initialize it first, okay. Every time you use a variable, so you need to initialize it first, okay. You can use unsigned, ingat lagi tak? Unsigned char Z, okay. Make sure that you initialize the character Z dahulu, okay, before you can use it. If not, the compiler, okay, will give you an error, okay, because the Z is not recognized by the compiler. Okay, so this is without the pull-up resistor. Kenapa without the pull-up resistor? Because why? Because you have the input port, DDRC, but you not enable the pull-up resistor. Okay, okay, you have the input, which is connected to port C, but here, if you can see, there is no pull-up resistor enabled. So next, let's look at the next. Okay, so this is an example of the same code, but with a pull-up resistor activated for port C. So only one line here needed, okay, to enable the pull-up resistor. Okay, so out port C R16, which is now port C R16 is value FS. So port C sekarang ni ada FF. Okay, similar to this one here, okay, you just simply write port C equal to FF to enable the pull-up resistor. Okay, here, inside here, okay, you just tambah, okay, add one instruction, which is port C sama dengan OXFF, then what happened here, your port C now, the pull-up resistor inside of the port C is enabled. Okay, so this is how to enable the pull-up resistor. Okay, so let's look at this another examples. Okay, so the AVR assembly code below show how to configure the pins of port A. Okay, so now here, okay, if you look at this program here, DDRA equal to OXFF, what happened here? You're going to make the whole port A as an output port. And when you write DDRB equal to 0, so means that you're going to initialize the whole port B as an input port. And when you write DDRC equal to OXF0, so what happened here is, okay, so if you're not sure what is the F0, okay, so you can change to binary representation. So F is 1, 1, 1, 1. 0 is a 0, 0, 0, 0. Okay, so now you know that. Okay. Pin C7 to pin C4, okay, you're going to make it as an output. While PC3 to PC0, you want to make it as an input port. Okay, so this is what happened. Okay, according to this program here. Okay, and then let's look at another examples. Okay, so the following code will toggle all 8 bits of port B forever with some time delay between on and off state. Okay, for example, Okay, so this is your Atmega 32. And then you have a port B. And this port B here, you connect to LEDs, for example. Right. So by looking at this, what we call here, program. Okay, first include the avr/io.h. Okay, and then this is your main program. Initialize your port B as a output port. Okay, so port B sama dengan output. And then while one, because you're going to make it a forever lah. Okay, the loop will be forever loop. Okay, so you use a while one. Okay, and then you see a port B equal to 0B01010101. And then after that, what happened here? You're calling a delay. Okay, so this is a delay. You're going to call a certain delay. And port B sama dengan 0B101010, and then you call another delay. So let's this one here, I make it as a sequence number 1, and then this is a sequence number 2. Okay, so this is a port B. Port B is connected to LED, so you draw your LEDs something like this. Okay, this is a LED 0 and this is LED 7. Okay, since this is a common cathode, okay, so what happened here is if you give 0 LED turn off, give 1 LED turn on. Okay, for the first cycles, so what happened here is this LED, okay, the value that you send is 0101 0101 to your LEDs. LEDs is connected to port B. Okay, so what happened here is this LED will turn on while the odd LED is turned off. Okay, so this is the cycle number 1. Okay, when cycle number 2, what happened here is, okay, you set another value, which is 10101010. So what happened in cycle number 2? Okay, the odd LEDs will turn on while the even LED will turn off. Okay, so now you see the blinky pattern between pattern 1 and pattern 2 with a certain delay. Okay. Okay, another example. Okay, we have a lot of examples for this I/O programming. Okay, you're going to write a program to perform the following. Okay, keep monitoring PB2 until it become high. Okay, so you draw your Atmega 32. Okay, you have a PB2. So this is your PB2. Okay, connected to monitor. Okay, so monitor means that it connected to your switch lah, until it become high. Okay, what is the meaning become high? Until it become high means that your switches is a normally low. Okay, it's an active high switch. Okay, every time you press your switch, it will produce high volt. Okay, logic high. So this is you connect to VCC. Okay, when you press, it will produce 1. When you not press, it produce 0. Okay, then when the PB2 become high, okay, what happened here? Write value 45 to port C. So you have a port C. Okay, when PB2 equal to 1, okay, port C sama dengan 45. And then pada masa yang sama, at the same time, send a high to a low pulse to PD3. Okay, you have another one here. Okay, and then send high to low pass. What is high to low pass? Means that you have the square wave lah. Okay, first you send high, and then after that you send low. Okay, so you have a certain duration here. Okay, so there is a certain delay to create this square wave, for example. Okay, so and then PD3 produce a square wave. Okay, high with to low. Okay, how to do this program? Okay, so we have all the information here. Okay, you already sketch your ATmega 32 circuits. Okay, from this information, okay, you can started your program, okay, by write down this header here, okay, avr/io.h, okay, and then start with your main program. Okay, the first thing that you're going to do here is initialize all the input port that you're going to use. Okay, since you have a PB2 connected to switch, okay, so why not DDRB? So just initialize the whole port B as a input port, okay, with a 0. Or, okay, this is another way lah. Okay, just initialize PB2, only PB2 as an input, which is this one here, is equivalent to, if you write something like this, DDRB equal to 0B11111011. Okay, so this is PB2. Okay, what happened here is, okay, if we look at this program here, okay, so this is shift 1 to the left. How many times? 2 times. Okay, you have value 1. Okay, so this is your value 1. And then shift to the left. Berapa kali? 2 kali. 1, 2. So it become here. Okay, the rest will be 0. And next, what happened? You have a tilde. Okay, what the tilde do? Means that you're going to do a complement. Okay, which is, this is a not operation. So what happened when you do this tilde here? It become complement lah, which is 0 become 1, 1 become 0. So this is the, after you put the this not function here, 1, 1, 1, 1, 1, 0, 1, 1. So this is equivalent to this actually. Okay, you see, bit number 2 get 0. But the rest of the bit get 1. Okay, so initialize your port B as an input. So I already did that because we doesn't have any port B. Okay, that become an output. So why not I make it for the whole port B as an input? And next, because this is connected to switch, okay, do not forget to enable your pull up resistor. Okay, how to enable pull up resistor? By sending 1 to your port B. Okay, so OXFF. Okay, so this is what happened lah. Or I can simply put, okay, so this is correct lah. Okay, port B sama dengan OXFF. Okay, next. Okay, so this line here, you see port B sama dengan put 1, okay, you have a 1 shift to the left by 2, okay, which is quite similar lah. Okay, you have this one here and shift to the left by 2, so you will get this value you set it to your port B, so only PB2 is enabled, the pull up resistor, but while the rest of the bit no need to enable. Okay, then port B is finished. Then we have a port C, okay, which is the port C is going to send this value. Okay, since it's going to send this value to display this value, so port C you need to make it as a output port. So DDRC sama dengan OXFF. Okay, make the whole port C as an output port. What about the PD3? Since the PD3 also you're going to display this square wave here, okay, which is from the logic high to logic low. So DDRD also you can make it as a output port. Okay, so DDRD sama dengan OXFF. So I just make the whole port D, okay, DDRD as a output port. Okay, for this one here, you see only PD3 is initialized as a output port. Okay, you have a 1, okay, kosong, 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 kosong. And then shift to the left how many times? 3 times. 1, 2, 3. Okay, and then this value, you put it to your DDR-T. So what happened? Only PD3 become an output port while the rest of the pin become input port. Okay, so next, okay, you're going to monitor. Okay, so monitor means that, okay, we're going to check it continuously. Okay, so by using a while loop. Okay, so open your while loop here. While one. Okay, this is quite longer. Okay, so now we're going to check whether it is equal to 1 or not. Okay, this value equal to 1 or not. How to do that? Okay, by using the if statement. If pin B. Okay, why pin B? Okay, kenapa pin B? Because this is a, okay, you already initialize your port. Okay, sorry, you already initialize your port B as an input. So since this is a input, so you need to read a data from pin B. So pin B, is it a pin B sama dengan 1? Okay, which is 0B0000 and 0100. Okay, you're going to check, is it a PB2 equal to 1? Okay, if yes, why? Yes, okay, bagi 45 to port B. Okay, so if yes, what happen here? Port port C equal to OX45, and then, okay, generate a high to low pulse to PD3, and port D sama dengan, okay, you can put something like this, 0P 0000 1000. So now you put a 1 to your PD3. So this is your PD3. And the next cycle is port D. You should call a delay lah in between. If not, it will happen quickly. Okay, you cannot see this low to high signal. Okay, so you're supposed to put a certain delay here to see the low to high signal. Okay, and 0B 0000 000. So now you send a low signal to your port D, which is a PD3. And after that, okay, close your curly bracket. And if not, else, okay, you just simply put a else. Okay, what you're going to do? Okay, nothing. Okay, just put something like this and end your while loop. Okay, and lastly is your end your main program. Okay, so this is the things lah, okay, to monitor PB2, the switches from PB2, either is high or low. Is high, then send this value 45 to port C and send a high to low signal to the PD3. All right, any question up until here? Ada soalan tak? Okay, so let's look at the elementary I/O. Okay, so what is elementary I/O? Okay, so elementary I/O is a two-state peripheral device which allowing to state a condition. Okay, so example of peripheral I/O is a bulb. Okay, why is bulb? Because the bulb, okay, you have a menthol here, the bulb. Okay, the bulb can be either is a turn on or turn off. Okay, you have only have two state, either is a lights on or lights off. Okay, logic 1 or logic 0. Okay, another elementary I/O such as switches. Okay, so the switch, either you press the switch, it will produce logic 1, or you release the switch, it will produce a logic 0. So depending on the switch lah, either you use an active low switch or active high switch. So in AVR, it can involve more than one bit at a time. Okay, contohnya BCD. What is a BCD? Binary code decimal, or the 7 segment. Okay, for the 7 segment, you have 8 LEDs at the same time. Okay, so instead of 1 bit, okay, you control for 1 bit. Now you need to control for 8 bits. Okay, so the requirement, Okay, bit signal can be written to the output device under a program control, and bit signal can be read from the input device under the program control. So in order to read and return the input and output device, you can use your program. Okay, so just remember lah to read. Okay, to read a data from the I/O. Okay, you need to use the pin X register. Okay, to write a data to the output. Okay, you can use the port X register. Okay, so there is a device required, okay, such as a latches, okay, 74 LS374. This is for the output, and tri-state buffer such as a 74 LS4244 for the input. Okay, so example of output device such as a LED, bulbs, relay coil, 77 display, and an example of the input device such as your push button, proximity switch, okay, your sensors, rotary VCD decoder, and etc. Okay, so let's look at the first elementary I/O that you frequently use, okay, in your project or in your labs. Okay, so first let's look at the LEDs. Okay, so this is the introduction of the LEDs. Okay, it's a semiconductor device that convert electrical energy directly into the discrete color of lights. Okay, so this LED have two terminals. Okay, and you need to connect them correctly. Okay, so it have a anode and cathode, which is this is a positive terminal and negative terminal. Okay, you know how to identify the positive and negative, and this is a symbol of the LEDs. Okay, so this is a negative and this is a positive terminal. And the LED is easily damaged by heat. Okay, make sure that you need to put and extra cautious lah to your LED. Make sure that you put a resistor lah in order to limit a current that will go through your LEDs. If not, your LED might get damaged. Okay, so never connect an LED directly to a battery or power supply. So, okay, we always do this experiment. Okay, we always experimenting with these things. Okay, put the LED directly to LEDs, and we can see the LED will produce a bright color, and then suddenly it will dead. Okay, so and as I mentioned earlier, okay, do not directly connect your LED to your power supply or your battery. You need to have a resistor. Okay, so this resistor is used to limit the current that will go to your LEDs. Okay, so this is how you're going to put the resistor. Okay, so just put it okay to in between your source and LED. Okay, so this is the how to determine the resistor. Okay, I know that you already learned this in the apa ni? Kamu punya teori likra. Okay, circuit theory. Okay, so I just keep this one here. Okay, now we're going to see how to turn it on an LED. Okay, depending on this lah, depending on the connection of your LEDs lah. Either you're going to use the common inlet or common cathode. Okay, so this is your output pin, and this is the pin that connected to your what we call here to your micro piece, and this is a VCC. Okay, so positive connected to LEDs, and now what happened here? This is a resistor, and if you put 5, which is a logic high 1 to LEDs, what happened here? Since this is a common cathode, okay, if you put 1, is it a common cathode? No, this is a common anode, okay, because all anodes are connected to VCC. Okay, you see the all anode is connected to VCC. Since if you put 1 to your LED, since logic 5 is high lah, 1 and 1, okay, so no light. Why no light? Because there is no current flow from here to here. Okay, when you put 0 to your output pin, so what happened here? The current can flow because this is a VCC logic high, and the current can flow from high to low. So LED will turn on. Okay, so what would be the ideal resistor value, okay, you can use the 300 ohm or 1 kilo ohm depending on the source lah that you're going to use. Okay, so this is how you're going to connect the LEDs, okay, to your ATmega 32. Okay, if you have a 8 LEDs and you did a common NX, okay, so we have a 2 common net for the LED, 2 common configuration. Okay, so this one is okay, so this is your micro P. Is this is a connection of your LEDs? What happened here is we call it as a common cathode. Okay, so common cathode give one LED on, give 0 LED off. Okay, and then we have here VCC, and this is connected to your micro P. Okay, so this is what we call it as a common cathode. Kenapa common cathode? Because positive terminal sambung kepada VCC and this negative terminal sambung pada ground. Okay, so this is a common cathode as common anode CA. Okay, when you give one, so what happen? The LED is will turn off, and when you give 0, the LED will turn on. Okay, so make sure that every time you get a question asking you, okay, to use a common anode or common cathode, make sure that you do it correctly lah. Because if you wrongly choose the common configuration and then suddenly you use the wrong numbers, okay, the wrong value sent out to your port, so what happen? The output will be wrong lah. So you will get 0 marks for that. Okay, and then this is another how to connect the LEDs. Okay, so this LEDs here, you see here, all the positive terminal LEDs are connected to 5 volts. So this one is a common. And then, okay, to turn on, you need to give a 0 lah kat sini at your output port. Okay, so let's look at the example for the LEDs. Okay, so you are going to write a program to count up and show the result of the counting by display 8 LEDs that are connected to port A. Okay, we already did this earlier, okay, in the previous slide. Okay, so I just draw this one here. So you have this one at Mega 32, and you have a port A. And inside of here, is it saying that using what type of a configuration? No. Okay, so just assume that we use the common cathode. Okay, so this LED is 8-bit lah. Okay, port A, you have 8 LEDs are connected to your port A. Okay, now what happens is okay, so LED will turn on according to the counting. Okay, so how to write a program? So this is how to write a program. Okay, so here, first, okay, this is what we always used to do lah. Okay, include this header file io.h. Okay, now define f underscore CPU, okay, and 1 million. Okay, means that you're going to define your CPU speed 1 megahertz and include util delay.h. Okay, why we need to do this one? Because you're going to use the delay function. Okay, inside of C program. Okay, instead of using a timer programming, you have another program, another function to generate a delay. We call it as a delay function. Okay, so this delay function, before you use it, okay, you need to include this library lah, this file here. Okay, so the delay that you can use is underscore delay underscore ms and then followed by the value. Okay, since this one here, you're going to generate 1 milliseconds. So what happened here, you just put thousands. All right, so this is a main program. Okay, since the LEDs are connected to port A, so what happened here is you need to ni lah. Okay, DDRA sama dengan OXFF, which is initialize your port A as an output port. And then, okay, unsigned char counter. Okay, so this is to, okay, you initialize the variable counter to counting up. Okay, because we're going to count up and show the result to port A. Okay, so initialize the counter here and give the counter value started with 0. Okay, and by using the while one, okay, so this will be done forever. Port A sama dengan counter means that you send a value kosong dahulu to your counter, and counter equal to counter plus 1. So the counter will increment by 1. And then after that, you call the delay. Okay, the delay MS. Right? So this is similar to what we did earlier. Okay, earlier we doesn't have this delay, now we have this delay. Right? So next we have the 7-segment display. Okay, so this 7-segment display is very important lah. Okay, because this one also you frequently use, okay, in the labs, in the your assignment, okay, to display a certain value in the decimal number. Okay, there are applications where you need to display a decimal digits, okay, using a 7-segment display. Okay, the display could represent the number of the time the switch has pressed or the number of time the counting, you do the counting sequence. Okay, so digit 0 to 9 and hexa A to F can be displayed by giving the proper 7-segment codes. Okay, so this is your 7-segment. I assume that all of you already, okay, know what the look of the 7-segment. Okay, the 7-segment actually have a 8 LED, total of 8 LED. Satu lagi kita letak kat situ. Okay, so make sure that the label is correct lah. So this is a A, B, LED B, C, D, E, F, G. Okay, silap. Satu lagi H. Okay, sometimes we have H, sometimes we doesn't have H. Okay, but most of the time we have a H. Okay, we have 8 LED, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this LEDs also have two common configuration. Okay, either is a common cathode or common NX. Okay, if a common cathode, okay, you need to give a 0 to turn off and give 1 to turn on. Okay, similar what we did earlier in the LEDs. Okay, common NX, give 0, it will turn on, give 1, it will turn off. Okay, so for example, okay, you're going to display number 6. Okay, so this is number 6. Okay, so you need to identify what is the value that you're going to send to your port. Okay, so assume that we use a common cathode. Okay, the simple one is a common cathode lah. Okay, so LED that you're going to turn on is A, C, D, E, and F. Okay, this A here, okay, this is a very important, yeah. Okay, remember A always your least significant bit. H always your MSB. Okay, so make sure that A, B, C, D, E, F, G, and H. Okay, sometimes you wrongly put the A become your MSB, H is your LSB, so the answer will be wrong lah later. Okay, so A, since this one here to display number 6, so A need to turn on. Okay, so you give 1 lah. B turn off, C lights up, D nyala, E also lights up, F, G, and H 0. So this is the value that you're going to send to your port. And then after that, the 7-segment will display this number correctly. Okay, if not, contoh lah, I give you, if you mistakenly, okay, put A here, 1, 0, 1, 1, and then 1, 1, 0, 0. So what happened here is Okay, so let's find out what is the character that will display if you put something like this. Okay, so the A is turn off, B turn off, C nyala, this one nyala D, E also nyala, F nyala, G turn off, and okay, so you will get this character here, which is wrong. Okay, so make sure that the position of LEDs A and LEDs H is correct before you find out what the value that you're going to send to your box. Okay, G tadi, sorry G tadi. Okay, you're not telling me that G is supposed to be 1 because D is a G. Okay. Okay, so as I mentioned earlier, okay, 7 display have two types. Okay, one is a concatenated and the second one is a common init. Okay, so for the common catenated, all of the catenated are connected to ground, and for the common init, all of the inits, okay, you see here, all of the init here are connected to VCC. Okay, that is the difference between common init and common catenated. Okay, so this is how the common catenated and how the common init works. Okay, for the common catenated, okay, give a logic 1, okay, to turn on the LEDs. And for the common init, give a logic 0 here at your output port, okay, so that the LED will turn on. Okay, so jadi kena hantar 1 to make it turn on. Okay, so example. Okay, if 0B001111 was output of the port B, okay, the following segment will be on. Okay, you need to figure out what is the value that will display on this 7 segment. Okay, so since this is your 7 segment, you have A, B, C, D, E, F, G, and H. Okay, sometimes H duduk sini and sometimes H duduk here. Okay, you need to look at this the figure. Okay, so now since okay you look at this one, this is a negative, means that you're using a common catenated. Okay, so common catenated 1 is turned on. Okay, so this is a value 0 0 1 1 1 1 1 1. So this is a B C D E F G and H. So the LED that will turn on is A B C D E and F. So it will display number 0 to your 7 7. Okay, let's look at another examples. Okay, a 7 segment is connected to port C. Okay, so you have a port C here connected to 7 segment, and then you're going to write a code that display 1 to the 7 segment. Okay, so you need to write a code to display number 1 on the 7 segment. Okay, to display number 1, first, what you're going to do here is before we writing a code, we need to find what is the value that you're going to send to your port C. Okay, so port C sama dengan, okay, what is the value that you're going to send to port C? So this is your 7 segment lah. A, B, C, D, E, F, G, H. Okay, since you're going to display a 1, okay, so the value, the port C here should be, okay, LED should be B and C turn on while the rest turn off. Okay, so you just simply write. Assume that we're using a common catenated. Okay, so this is the value that you need to send to your port C. Okay, so how to write a program? Okay, again, hashtag include avr/io.h. Okay, and then start your main program. Sorry, int main void, open curly bracket and close curly bracket. Initialize your port C, so your port C become output port. DDRC sama dengan OXFF, and then send this value to your port C. Okay, so port C sama dengan 0B 0000 0110 if you're going to use a binary representation, or you can simply write port C equal to 0x06. Okay, so now what happened? Your LED here will be, okay, sorry, your 7 segment will display number 1. Okay, we have a few minutes left. Okay, so now we go to another examples. Okay, right. A 7 segment is connected to port A. Okay, write a code that display 3 on the 7 segment. Okay, so let's this is a port A. Connected 7 segment connected to port A. First, what you're going to do? Okay, identify the value that you're going to send to port A so that it will display number 3. Okay, so A, B, C, D, E, F, G, and H. Okay, so this is your port A. Okay, LED that you need to turn on is A, B, C, D. So A, B, C, D will turn on. E, F turn off. G turn on. H is turn off. So this is the value that you're going to send to your port A. Okay, so started with your main program. Okay, hashtag include avr/io.h. Okay, and then you start with a main program. Okay, and then initialize your port A, DDRA equal to OXFF, so that your port A become output port. And after that, send the value port A equal to 0B. Okay, and then send this value here. Okay, 0100111111, or port A equal to OX. Okay, what would be the value here? If you change to binary hexadecimal, berapa value dia kat sini? Anyone? Okay, just use the 8421 method. Okay, what will be the value?
For for F.
For F. Okay, correct. Okay, so by using the 8421 ya, 8421, 8421. So this is a 4, and this is a 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, 15 is F. So 5. Okay. So let's look at another examples. Okay, and then after that we call it a day, and then the rest we continue next weeks. Okay, so a switch is connected to pin B0 and LED to PB7. Okay, you draw your circuit dahulu. You have a switch sambung ke PB0. Okay, so I just put this is your switch. Okay, so according to this one here, this is active low switch or active high switch. If you're looking at this figure here, is it active
Active
low
high.
or active high?
Hmm.
When you press the switch, what would be the input coming to your Atmega? 1 or 0? Okay, you
One.
have the switch. Okay, you press the switch. What happened? When you press the switch, okay, so it will go here, kosong. When you not press the switch, okay, it will always give 1. Okay, so this one here we call it as active low switch lah. Bila press switch, it will give 0. And sometimes we call it as a normally high. Means that the switch always produce 1. Okay, so this is a normally high switch. When you press and it will give 0 value. So this is a active low switch lah. When you press je, dia akan produce 0. Okay, so this is a VCC. Okay, so make sure that you know how to identify between the active low switch and active high switch. All right, so this is another important things lah. Okay, when you do your projects and when you answer the final exam question or test question. And then you have a LED connected to PB7. Okay, so this is a PB7. I just put it around here. And this PB7, you see here, you have something like this. And okay, you need to identify lah, what type of this LEDs here. Okay, so this is just common, scattered or common in this LED. Okay, if you're looking at this picture here. Negative go to ground. So this is a common, scattered. Okay, so turn on, give 1. Off, give 0. All right, and then write a program, okay, to get the status of the switch and display it at the LED. Okay, you need to write a program, okay, to check whether you press your switch or not. Okay, if you press your switch, what happens? LED will turn off. If you not press your switch, LED will turn on. Okay. When you press, okay, it will give 0 lah. Okay, when you press, which is a give a 0, LED off. Okay, press switch, LED off. When you not press, it will give a logic 1 and LED. So this is what you get from this information here, the information that you get from this question. Okay, so now we write the program. Okay, started with the hashtag include avr/io.h. Okay, and then int main void, open curly bracket and close curly bracket down there. Okay. So sekarang ni, if you look at this port here, okay, you have 2 port here. Sorry, you have a 1 port, and this port here, you have input and output at the same time. Okay, so you have a port B, okay, which is DDRB. Okay, now you're going to determine what is the value of your DDRB. Okay, so PB0 switch means that bit 0 you need to give 0 because this is a input. Okay, you something like this, just write in binary. Okay, easy to you for you to look at the bit number. Okay, so this is 0. Okay, because this is PB0. Okay, PB7 connect to LEDs, which is your output lah. So this is a PB7. Okay, what about the rest of the pin? Okay, you can either make them as an input or as a output. Okay, so for the marking, okay, we're only looking at this bit. Okay, we doesn't care what is the value that you're going to put in between of this bit here. Okay, we're only looking at this PB7 and PB0. So in this case here, I just make the other bit as a output. Okay, so 1, 1, 1, and this is 1, 1, 1. So this is the value. Okay, so DDRB 0B1111 1110. So what happened here is PB7. Okay, you make it as an output, and PB0 you make it as a input. Okay, next, what are you going to do? Okay, since this one here, okay, you can see here, this is PB0 is connected to the switch. So you need to enable the pull-up resistor. Okay, how to enable a pull-up resistor? By put 1 to your port. Okay, so port B sama dengan, okay, 0B. Okay, since you see here, only this bit here you need to send 1. Okay, you need to enable the pull-up resistor. What about the rest of the bit? The rest of the bit, you disable the pull-up resistor. Okay, because we're going to reset the pull-up resistor. Because here, okay, from this bit, okay, you make it as a output port, betul tak? For the output port, whatever value that you're going to send out, you need to use the port B. register. So that's why, okay, we initialize our port B with this value. Okay, only this one here enable for up register. Okay. Okay, next. Okay, what are you going to do? Okay, Y1. After you initialize, okay, then you can start with your program now. Okay, why we need to use a Y1? Okay, because we're going to monitor. Get the status. Okay, get the status means that you're going to monitor continuously. Okay, so open curly bracket and close curly bracket. Okay, what you're going to monitor? The PB0 value. Either it is pressed or not pressed. Okay, so let's look do a if else statement. If pin B sama dengan okay 0B 11111110. Okay, you're going to check whether it's equal to 0 or not. If yes, what happens if yes? LED off. Okay, so open curly bracket, close curly bracket, port B sama dengan okay port B. Okay, do not simply put this one yeah. If you put this one here, port B sama dengan kosong means that you disable. Okay, you use disable the pull up resistor. Okay, you already disable the pull up resistor. We need the pull up resistor always enable. Okay, if you put a 0, what happen? The pull up resistor will be disabled. So that's why I use the port B sama dengan port B. Okay, and then end with 0B 0. The rest I put 1. Okay, why I put something like this? Okay, because I'm just going to clear this bit only. Okay, the rest of the bit, the value remains. Okay, so this is what happened lah. Or if you confuse, okay, if you don't want to do something like this, okay, if you confuse, okay, you can simply write port B sama dengan 0B, okay, 1 S hantar satu LED off ya. LED off is sorry. Yeah, LED off is 0 lah. 0. Alright. 0 0 0 0 0 0. Okay, here ni kena 1 because this is a PB 0. Or you can simply write something like this. Also correct. But this is not a good way lah. Okay, this is not the good way to write a program. Okay, this is the good way lah to write a program, which is okay, we put a masking to our port B with this value and do a logical AND. Okay, let's say your port B now is this value here. Okay, currently this is a current value of your port B. Okay, and then you AND with this value 011111111. So what happened here is 1 AND with 1 you will get 1. Okay, 0 AND with 1 you get 0. This is a 0 0 0 0 and 0. Okay, sorry, another 0 here. So you see here, this will clear your PB0 and the rest of the bit here remains. Okay, that is what happened. Okay, when we do the masking techniques. Okay, why else? Open curly bracket, close curly bracket. Okay, so what if this port B0 is not equal to 0? So what happen here? Okay, so the LED will turn on. Okay, so port B sama dengan port B. Okay, we do a masking techniques here. Okay, now we use the OR. Okay, every time you're going to clear, we use the AND. Okay, remember yeah? Every time you're going to clear a certain bit, use the AND, logical AND. Every time you're going to set, you use the logical OR. So what would be the value? Okay, 0, B, 1, 0, 0, 0, 0, 0, 0, 0. So what happened here is after you do this here, okay, so this is the current value lah. Okay, the current value of your port B. And then when you OR with this value, so what happened? Dia akan jadi 1, 0, 0, 0, 0, 0, 0, 0. Do a logical OR. You see here, this value remains. Okay, PB0 remains. The rest follow. 1 or with 0, you will get 1. So now PB7 jadi 1. Turn on. Okay, the rest masih lagi follow previous value. That's why we do the masking. Okay, so this is wrong. Okay, this one is wrong. Kenapa salah? Sebab you disable the PB0, the pull up resistor at PB0. Okay, if you're going to use it, you can simply write port B sama dengan 0B 1 0 0 0 and 0 0 0 1. So this is the correct way lah. Okay, not this one. Okay, any question up until here? Ada soalan tak? Okay, we just stop here.